Have you ever wondered why a soccer ball flies through the air when you kick it? Or why a car speeds up when you press the gas pedal? What makes things move? And what makes them stop? These are the kinds of questions we answer with a fascinating branch of physics called dynamics. Welcome back to our channel. Today, we're diving deep into the world of dynamics to understand the forces that govern everything around us. So, buckle up, because we're about to explore the why behind motion. First things first, what exactly is dynamics? In simple terms, dynamics is the study of why objects move the way they do. It's all about the relationship between motion and the forces that cause that motion. Think about it. A book doesn't just slide off a table on its own. A force, like a gentle push or the pull of gravity, has to act on it. Dynamics helps us understand and predict how that book will move once the force is applied. It's the physics of pushes and pulls, and it's happening everywhere, all the time. Now, you might have heard of another term called kinematics. It's easy to get them confused, but they are two sides of the same coin. Kinematics is the what and how of motion. It describes motion using concepts like position, velocity, and acceleration. For example, kinematics can tell you how fast a car is going or how far it has traveled. It's like being a sports commentator describing the play-by-play of a race. You'd say, the car is accelerating at 5 meters per second squared and has reached a speed of 100 kilometers per hour. Dynamics, on the other hand, is the why. It doesn't just describe the motion, it explains what's causing it. Going back to our car example, dynamics would ask, why is the car accelerating? The answer would involve the force from the engine, the friction from the road, and the air resistance pushing back. So, kinematics describes the movie of motion, while dynamics explains the director's choices and the script that makes it all happen. In short, kinematics is the description, and dynamics is the explanation. The foundation of dynamics was laid by one of the greatest scientific minds in history, Sir Isaac Newton. His 3 laws of motion are the fundamental principles that explain how forces affect objects. They are incredibly powerful and apply to almost every situation you can imagine, from a tiny dust particle floating in the air to planets orbiting the sun. Let's break down each of these laws with some simple, everyday examples. Let's start with Newton's first law, also known as the law of inertia. This law states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction unless acted upon by an external force. Inertia is just a fancy word for an object's resistance to a change in its state of motion. The more mass an object has, the more inertia it has. Imagine a soccer ball sitting on the grass. It's not going to move until someone kicks it. That kick is the external force. Once it's kicked, it will keep rolling. But why does it eventually stop? Because of other forces like friction from the grass and air resistance. If you could kick that ball in the frictionless vacuum of space, it would theoretically keep going forever in a straight line at a constant speed. Another great example is when you're in a car that suddenly stops. Your body wants to keep moving forward because of inertia. That's why seatbelts are so important. They provide the force needed to stop you safely. Now let's move on to Newton's second law of motion. This one is often expressed as a famous equation. Force equals mass times acceleration, or F id has ma. This law tells us what happens when a force is applied to an object. It says that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Let's unpack that. Directly proportional to the net force means if you push something harder, it will accelerate faster. If you push a shopping cart with a little bit of force, it moves slowly. If you push it with all your might, it accelerates much more quickly. Inversely proportional to its mass means that for the same amount of force, a heavier object will accelerate less than a lighter one. Imagine trying to push an empty shopping cart versus a cart full of heavy groceries. You use the same amount of force, but the full, more massive cart accelerates much more slowly. edtech is the engine of dynamics. It allows us to calculate exactly how an object's motion will change when forces are applied. Finally, we have Newton's third law of motion. This one is probably the most famous. For every action, there is an equal and opposite reaction. This means that forces always come in pairs. When you exert a force on an object, that object exerts an equal and opposite force back on you. Think about a rocket launching into space. The rocket's engines push hot gas downwards. That's the action. In response, the gas pushes the rocket upwards with an equal and opposite force. That's the reaction, and it's what propels the rocket into the sky. Or consider something as simple as you standing on the floor. Your body exerts a downward force on the floor due to gravity. At the same time, the floor exerts an equal upward force on your feet. This is called the normal force. If the floor didn't push back, you'd fall right through it. Even when you swim, you push the water backward with your hands, action, and the water pushes you forward, reaction, allowing you to move through the pool. So, to quickly recap, dynamics is the study of why things move, connecting forces to motion. It differs from kinematics, which just describes motion. The entire field is built upon Newton's three laws. The first law, inertia, tells us that objects resist changes in motion. The second law, edtech, gives us the mathematical relationship between force, mass, and acceleration. And the third law shows us that forces always come in pairs. Action and reaction. Understanding these concepts is crucial because they are everywhere. They explain why you can throw a ball, why cars need engines to move, why airplanes can fly, and why planets stay in their orbits. Every time you walk, jump, or even just sit in a chair, you are experiencing the principles of dynamics in action. It's the invisible script that choreographs the dance of the universe, from the smallest particles to the largest galaxies. By understanding dynamics, we gain a deeper appreciation for the elegant and predictable rules that govern our world. I hope this has helped you get a solid grasp of what dynamics is all about. It's a fundamental part of physics, and once you get the hang of it, you'll start seeing it everywhere. If you found this video helpful, be sure to give it a thumbs up and subscribe to our channel for more science explained simply. Got any questions? Drop them in the comments below and we'll do our best to answer them. Thanks for watching, and we'll see you in the next video.